things. All right, here we go. 4.3, solving linear systems by elimination. All right, so again, I think my voice is going to hang out with us, so I'm not going to play the video. I'm going to teach it for you. So follow these steps when solving by elimination. When we're solving by elimination, we want to arrange the equations with like terms and columns. So essentially, we want to make sure that we're lined up as AX plus BY equals C. Okay, so that's the format. We want to be in standard form. Okay, the next thing is we're going to decide what term we're going to eliminate, and you're going to circle that. The goal is not saying opposites, which means that one has to be positive and the other has to be negative, or they will not eliminate. Does that make sense? Okay, the only way to cancel out is if you have a positive or negative. Step 2 is to find an LCM, least common multiple, each term of one or both of the equations by an appropriate, multiply by an appropriate number, okay? So LCM is what is the smallest number that both can divide evenly into, right? So let's just do a little middle school check. If I ask you for the LCM of 2 and 3, what is the LCM of 2 and 3? What is the smallest number that 2 and 3 both divide evenly into? 6. The least common multiple is 6. If I count by 2s, can I get to 6? If I count by 3s, can I get to 6? So my least common multiple is 6. What is the least common multiple between 4 and 8? It would be 8, right? If I count by 4s, can I get to 8? If I count by 8, can I get to 8? Yes, that's what a least common multiple is. What is the smallest number that they can both evenly divide into? Make sense? All right, so finding your LCM. Then you're going to add the equations, okay? Adding the equations is basically combining like terms, right? Okay, then we're going to solve for the remaining variable. On step 5, you can substitute or you can do elimination again. It really is up to you on which way you want to go. But substituting is good if it's an easy number. Elimination is probably better if it's a complicated fraction, okay? And then we're going to check the solution and go from there. All right, pay attention, focus. Phones should be down, computers should be closed. All right, example 1, what is the solution of the system of equations? So here we have 2x minus 5y equals 11. And then we have 3x minus 2y equals negative 12. Okay, so we're going to solve it by elimination. Step 1 is to make sure you're in standard form. Are they both in standard form? Yes. And you're going to decide which variable do you want to eliminate. Do we want to eliminate x or y? We're going to do x. All right, so we're going to eliminate x. So step 2 is find your least common multiple of those coefficients. So what is the least common multiple for 2 and 3? 6. Does that make sense? So after that, it says multiply each term of one or both equations by that number. So my question is, how can I turn 2 into 6? Multiply by 3. So I'm going to multiply everything here by 3. Does that make sense? How can I turn 3 into 6? Times 2. I'm going to multiply everything here by 2. Notice that what I do to one side, I do to the other. Now, they have to be opposites because these are currently both positive. One has to turn into a negative. I always just make the bottom one a negative. It just makes it easier. Call it a day. There's no other reason or rhyme.
So does it matter which way 2 and 3 goes?
It doesn't matter which one is positive or negative, as long as one is, because the goal is to eliminate. And if one is not positive and one is not negative, will they eliminate? No. Okay, so now our next step, it says add the equations. But before we can add the equations, we got to finish this part here. So what are my new equations that I'm working with? So this becomes what? 6x negative 15y equals 33. And what is my next new equation? Plus 4y equals 24. Okay, so do we see how we created new equations? And now what eliminates? So step 3, we eliminate, and we're left with what? Negative 11.
No.
57. All right, step 4 is to solve for your variable. Can I solve for my variable? What do I need to do to get y by itself? Divide by negative 11. So what is y? Negative 57 elevenths. So we now have y. At step 5, we have 2 options. Option number 1 is to go back through the elimination process and this time eliminate our y because we know the value of y. Option number 2 is to plug this into one of the values. Which one do we want to see modeled? Do we want to see another elimination again? Or do you want me to see it with substitution? Elimination? All right, so we're going to go back through with elimination. So I'm going to go back to step 5. And this time, instead of eliminating our x's, we're now eliminating our y. So you ask yourself, what is the least common multiple of 5 and 2? And what is that? 10. So that means I need to change each one of these into a 10. Does that make sense? How do I change 5 into a 10? Multiply by 2. How do I change 2 into a 10? Okay, since they both are the same size, one of them has to be negative. I always just make the bottom one. Doesn't really matter. So I go ahead and distribute. And we get 4x minus 10y equals 22. We have negative 15x plus 10y equals 60. What happens here? The y's canceled. 4x and negative 15x make negative 11x. 22, bless you. Was that a sneeze? Or was it a laugh because you're not paying attention? Because I know I'm not doing anything funny. So we get x equals negative 82 over 11. So our solution set is negative 82 over 11, comma, negative 57 over 11. Do you see how if we use substitution, that may not have been a pretty number to work with through the end, right? Especially if it's wanting the exact value.
Well, that's for step 6.
Step 6 is to check yourself. 6 is to check yourself. So check your solution. So those are my solutions. If I wanted to plug back in to make sure they work, make sure I did it correctly. I don't know why my headband won't stay on my head. It's really bothering me. I think I'm not meant to wear these kind of headbands. Like, why won't it stay? All right. Guess what? It's your turn to try. Okay. I gave y'all prettier numbers. So you're going to do practice 1. All right. So, huh? Step 6 is to check your solution. It's at the bottom of your step 6. Yeah. All right. So y'all are here and go. All right, so let's see how we did. So, start off with, did y'all just eliminate, what y'all choose to eliminate? We said X, majority said X?
Yes.
Huh? I don't know. Okay, so we're doing X. Majority chose X. Draw your hands for X. Oh, okay, there we go. All right, so we're in form. Then we're going to determine our LCM. So the LCM to eliminate X, we have 3 and 12. So what's your LCM? 12. Okay, so do I have to change the first one? Nope, the first one's going to say 12x plus 8y equals negative 8. How do I change the second one? How to multiply everything by? How do I change 3 into a 12? Negative 4. And when I do to one side, I got to do to the other. So now I have negative 12x minus 16y equals negative 8. Agreed? So then my x's are going to do what? They are going to cancel out now. So now I can cancel out. So we're going through cancellation. That goes away. And we're left with, I have positive 8y and negative 16y. We're left with negative 8y equals negative 16. So then we divide by negative 8. What are you doing? Okay. So y equals a negative divided by negative is a positive. So step 4, we go through and solve, and we get y equals positive dose. Yes? Okay, step 5 is to decide. At this point, is this going to be an easy number to plug in, or should I do elimination again? I feel like 2 is an easy number to plug in, guys. Oh, I was like, I would have just plugged in 2. So 3x plus 4 times 2 equals 2. So that gives me 3x plus 8 equals 2. Now it's just a linear problem. What do I need to do to get x by itself? Subtract 8 from both sides. And we get 3x equals negative 6. And then my last step, divide by 3. So we get x equals negative 2. So on 6, my solution is negative 2 comma 2. And if I don't feel good about it, what do I need to do? Check myself, plug it back in and check and see if it works. I really think I'm broken that I can't write 2's the same every time. It's really concerning. Close enough. All right. So this was the first one was an example of where doing second elimination probably is better because of the fraction, right? This one is an example of when you have a fairly easy number to plug in, why not substitute instead of doing elimination? Do we see the difference? Yes? Okay. All right. So last one. You got this. All right, so first thing first, you gotta decide which variable you want to eliminate. What variable were y'all going for?
X.
We're gonna decide on X, okay? We're already in standard form. We're gonna eliminate our X. Next, we're gonna determine what is the least common multiple between -2 and positive. Well, doesn't matter, it's negative. But between 2 and 10, what's our LCM?
5.
Our LCM is 10. Yeah. Multiplied by 5. There we go. So I'm gonna have to change this one by multiplying everything times 5. Agreed? So now we have -10x minus 20y equals 10. Do I need to change this one? Nope, it's already 10. So we have 10x plus 20y equals -10. Okay, step 3, we're now going to eliminate. What do you notice happens? Everything eliminated. Oh no, I did something wrong. No, you didn't. When this happens, that means that it is infinite solutions. I think that's just spelled infinite. Infinite solutions. Okay, what that means is that these are the same line. They're going to be coinciding. That's our dependent consistent solution. So when we think about it, that's a dependent consistent or consistent solution. Okay, now just FYI, note to self. So FYI, if 0 equals anything else than itself, so if 0 equaled 1, then that is a no solution. Because does 0 equal 1?
Oh.
No. So if it makes a untrue statement, that's how you have no solution. Got it? Do we see the difference between infinite and no? Okay, and there's no solution. That means that they're parallel and they'll never, ever, ever touch. Okay. All right. So you should have picked up your assignment. Your assignment is due Monday by 11:59 p.m. So either you turn it in on class or you submit it on Canvas. But it's due Monday by 11:59 p.m. Yep. Okay. All right. They go straight in your box. I didn't grade it in the basket.
So you never grade things in the basket?
I do grade things in the
Yeah, well,
basket.
I have a system, I don't think it- So you want it on Canvas too?